Well, welcome grade 10. This is your grade 10 term 1 test revision. These are the questions that will be likely in your test. So let's just get into it. Okay, so I've got question 1.1 and it says, are the following expressions rational, irrational, or not real? Okay, let's look at 1.1. If I can see it's x to the power 3, it gives me a definitive answer, which would always be rational. So this one is just simply rational. Remember what rational numbers are. These are numbers that can form whole numbers and also fractions of whole numbers, right? So let's look at 1.2. This one will not give me, it will not give me a perfect answer, a whole number. It will give me a decimal, the cube root of 25. So this one is definitely irrational. Okay, irrational. Okay, then 1.3, 2 over x, x is an integer, so because it's a fraction of integers, that makes it rational. Okay, so that one is just rational. And then we've got 1.4. Now I've got x squared, which is a very rational, times pi. Now, because of this pi is irrational. Because of this irrational number of pi, that makes the whole thing irrational. So this one is irrational. Okay, so there we go, irrational. I write it down just like that. And then 1.5, even though it's a negative number, but it's a negative integer over another integer, and it's a fraction, that makes it rational. Rational. Okay, so that's it. They're all rational. Let's go to question number 2 now. Okay, let's do question 2 now. And we've got 2.1, and it says 2x, and then I've got x minus 1, and then minus 3 x squared minus 1. That's what I got. Okay, the English says expand the following. So in expanding, we do just that. We expand. We're not factorizing, we are expanding. So the first one is this one. It's 2x times x, which will give me 2x squared. The next one is 2x times minus 1, which is minus 2x. And then this one is minus 3 times x squared, which is minus 3x squared. Then the last one is minus 3 times minus 1, which is a positive 3. Okay, so combine like terms. I've got minus 2x squared. No, it's plus 2x squared minus 3x squared, which gives me minus x squared. And then this one is minus 2x squared, 2x plus 3. These ones remain. This is our final answer. Okay, let's look at now 2.2, right? Now I'm given 3x minus 2 and 5x plus 8. There we go. So the first one is 3 times 5, which will give me 15. And then I've got x times x, which will give me x squared. And then I've got, in terms of numbers, 3 times 8, which is plus 24. And then x times, well, there's an x times 1. It's just x. And then I've got in terms of numbers, minus 2 times 5, which is minus 10, and then 1, well, I've got an x there multiplied with a 1, and then there we go, minus 2 times 8, that gives me minus 16, right? 2 times 8 is 16. Now I combine like terms, 15x squared plus 24x minus 10x, that will give me plus 14x, right, minus 16. This is now fully expanded. We are finished with this question, which means we can move on to the next one, which is 2.3. Now we have x minus 1 and then x squared minus 2x plus 1. There we go. So principles don't change. I'm gonna say x times x squared, which is x cubed. Cubed is a 3. And then x times minus 2x, which is minus 2x squared. And then I got x times plus 1, which is plus x. And then minus 1 times x squared is just minus x squared. And then minus 1 times minus 2x is plus 2x. And then minus 1 times a positive 1 is just minus 1. There we go. Now we combine like terms. X cubed stays. And then minus 2x minus 2x squared minus x squared gives me minus 3x squared, as you know. And then I've got x plus 2x, which is plus 3x, and then I've got that minus 1. Okay, I think we're done now. That's it. Oh yes, yes. Let's move on swiftly to 2.4. Ooh, 2.4's got fractions. It looks a bit intimidating, but not to worry. We've got x minus 2 over x, close the bracket, open another one, and then we've got x over 3 plus 4 over x. Now don't be intimidated by fractions, but what I can do is make everything a fraction. So this x becomes x over 1. Okay, that's what it becomes. Therefore, principles don't change, numbers do. So I'm still gonna do this principle here. Now when you're multiplying fractions, remember, you multiply them directly. So x times x is equals to x squared. 1 times 3 is equals to 3, just like that. And then x times 4 is equals to plus 4x over 1 times x. You see that? Which is equals to x. Now these ones, minus 2 times x is just minus 2x over x times 3 is 3x. And the last one is minus 2 times 4, which is minus 8, right, over x times x, x squared. Cool. Okay, so combining like terms, this one just stays as it is, x squared over 3. Here, this x cancels with that x. And then here, that x cancels with that x. Then I'm left with plus 4 minus 2 over 3 minus 8 over x squared. And then finally, final answer is x squared over 3. This number, I need to put it in a calculator. So what I'm going to do is I'm going to get a calculator. Here we go. I hope you have this one, which is 4 minus a fraction 2. Come downstairs, you put the 3. So you put it exactly as it is. That gives me a plus 10 over 3 minus 8 over x squared. Now that is the final answer. Are we cool? I think we're done with question 2. Let's go to question 3. Okay, question 3.1. It says factorize the following expression. So it's 3.1. I'm given 2x minus 6x squared. Now remember what we're doing here. The English says factorize. Okay, so we have to do just that, factorize. So let's start with the numbers. In factorizing, you always look for the highest common factor. The highest common factor between 2 and 6 is 2, right? The highest common factor between x and x squared is x. Okay, and then I open the bracket to get 2x. I multiply 2x with 1. To get minus 6, I multiply 2 with minus 3. To get x squared, I multiply x with another x. There we go. Let's finish in one line. 3.2, I have 5a minus 2 minus b and then 2 minus a. Okay, so here I have inside the brackets, I have a minus 2 and 2 minus a, which means I need to change one of them to become the other. So what I'm going to do is I'm going to change this minus b1 by multiplying outside the bracket with minus 1. Okay, that's the operation you have to do. And then once I do that, I can swap what's inside the brackets. Okay, so I'm going to have 5. This one stays as it is. A minus 2. Now, minus times a minus gives you a positive. And then b, now I can swap what's inside and it becomes a minus 2. You see, instead of 2 minus a, it became a minus 2 because we multiplied the outside bracket with a minus 1. From there, I can see the common factor is this bracket of a minus 2 for these two expressions. I open this one. To complete this expression, I need to multiply a minus 2 with 5. To complete this one, I need to multiply a minus 2 with b. There we go. We are finished. That's it. Let's go to the next question. The next question would be 3.3, where we have 4x squared minus y squared. Now, is this a square number? 4, yes. Is this a square variable? Yes. Is this a minus? Yes. Is this a square variable? Yes. That means we're going to do the difference of two squares. It fulfills all the conditions, and we do that by opening two brackets, and then we say square root of 4 is 2, so I write 2 on both. Square root of x squared is x. I write x on both. Square root of y squared is y, so I write y on both. And then I just simply put a plus and a minus. That's it. We are done in one line. Let's go to the next one, which is 3.4. Taking it to the next level. Now I have 2x squared plus 5x plus 3. Okay, so this one we have to do a little bit of working to factorize this, but you're always going to take this number, this side, multiply it with 3, and it'll give me 6. And then now I'm going to look for multiples of 6 that are going to give me 5, right? So I've got 6 and 1. I've got 3 and 2. Okay. So actually I prefer writing it the other way around, so that y is always a factor. I write the factors of 6 this side, so it's 1 and 6. The second one is 2 and 3. Yeah, let's stop with these. So I need to add there so that they give me a positive 5, but also when I multiply them, they will give me a positive 6, because this sign over here is positive. So meaning when I multiply them, they must give me a positive sign. Okay, they must give me a positive 6. How do I get a positive 6? Okay, now using these two, I can get a 5 if I say plus 6 minus 1. 6 minus 1 is 5. So it satisfies this condition, the first condition. Now let's see if it will satisfy the second condition, where it gives me a positive 6. And it will never, because I have a negative here. Negative 1 times positive 6 gives me a negative 6. So I reject this one. Let's come here. 2 and 3. How do I get 5 using 2 and 3? Well, if I have plus 2 and plus 3, those two will give me 5. Okay, so if I say plus 2 times plus 3, or positive 2 times positive 3, that gives me a positive 6, which satisfies the second condition. So therefore I'm going to say 2x squared. Now I'll rewrite plus 5 in terms of what I have picked here, and I go with it exactly as it is, which is 2x plus 3x. 2x plus 3x, they give me 5x, right? So I'm just rewriting, and then I write this last part, plus 3. Now I will factorize these two together, and then I'll factorize these two together as well. All right, so watch this. In factorizing, I take out the common factor. Common factor amongst numbers is 2. Common factor amongst variables, it's x. And then to get 2x squared, I need to multiply 2x with x. Good. To get 2x, just with 1. I'm done factorizing the first two. Now let's factorize the second two. I take out the common factor between the two numbers, and it's 3. And I'm left with x plus 1. Now I can see that x plus 1 is a common factor amongst both expressions. So I take it out, x plus 1, and to get this whole expression, I multiply x by plus 1 with 2x. And then this side, I multiply it with plus 3. Now I am done factorizing. I have successfully factorized this thing. All right, let's go to the last question, which is, well, the last one in terms of question 3. That's 3.5. This time I have a cubed plus 27. Okay, so this one, because of this cubed, and this is a cubed number as well, that means I can do the difference of 2 cubes. Difference of 2 cubes, open a small bracket, and then you open a big bracket. On the small bracket, okay, I put a plus, the same sign as here, which is a plus. Okay, that's a small bracket. which means this side on the bigger one, I will put a minus and a plus. Now it has to be minus and plus. Do not change the order. If you say plus and minus, that would be wrong. Always keep it at minus and plus. Now, okay, for this first number, cube root of a cubed is just a. Cube root of 27, I think, is 3. Okay, just out of interest, how do we do the cube root on your calculator? You can see the root is orange on my calculator and shift is orange, so I start with shift and then I press there. Now I can put a 3 there, come downstairs, and I put 27. That's equals to 3. That's just a side note. Okay, now once you're done with these this small bracket, you now do the big bracket based on the small bracket. Square this first one, which is a squared. Square that last one. 3 squared is 9. And then you multiply both of, which is 8 times 3, which will give you 3a. A almost looks like a 9. But there we go. This is our final answer in just one line. Okay, I think we're ready for question 4 now. Okay, let's do question 4 now. 4.1. Let's look at that. We've got a x minus b plus x minus a b. This is all divided by a x squared minus a b x. Okay. All right, so let's see. It says simplify the following. So we're simplifying. In simplifying, we can factorize so that things cancel. Now, if I look at the first two here, I cannot really factorize these two, right? Not really anyway, because they're all different variables. Also, this one, can't factorize it. So what I'm going to do is I'm going to just rearrange them. I will bring the x this side so that it becomes ax plus x. And then I'll bring this b to the other side so that it becomes minus ab minus b. So all I did was just rearrange the top parts. This one, what can I do under here? It looks like I can I factorize? Yes, I can. I take out the a because a is common in both. What about b? B is not common. What about x? X is common. All right. And then to get ax squared, I need to multiply ax with an x. Minus, to get abx, I need to multiply ax with b. Okay, the thing on top that I rearranged, let's look at it. So what's the common factor between these two? Now I have a common factor. I also have a common factor here. So I can clearly see the common factor is x. So I take x out, and then I'm left with, to get ax, I multiply x with a. To get x, I multiply x with 1. So plus 1. This side, I'm going to take out a negative. Common factor between the two is b. Now, to get minus ab, I need to multiply minus b with a. To get minus b, I need to multiply minus b with plus 1. And then I divide by ax. Nothing to be done there. X minus b. Let's look at it. And then at the top here, I can see I have a common factor of a plus 1, right? And then to get this expression, I multiply a plus 1 with x. Okay, I just want to increase that. And then this side with minus b. And this is all divided by ax to the bracket x minus b. Now look at this. This x minus b cancel that x minus b, such that I am left with a plus 1 over ax. This is simplified now. I'm happy. And it stays there because I can't simplify any further. It just stays there. Okay. Now let's look at the next question, which is 4.2. 4.2, I have 2 to the power 2n times 4 to the power n times 2. This is all divided by 16n. Now, when it comes to these questions, exponents, you're always going to change the basis to their products of prime factors. So 2 is already a prime factor, so it's gonna stay as 2 to the power 2n times 4 is not a prime factor, but I can write it as a product of its prime factor, which is 2 to the power 2, and then there's an n which multiplies the exponent, so it's 2n, and then times 2. Now I want to put a power 1 here. You will see why, because 2 to the power 1 is the same as 2. I'm just gonna include that 1. 16, you need to change 16 to a product of its prime factors. Let's do this on the side. So I'm gonna have 16. So 16, the first prime factor, I'm gonna do a tree diagram. The first prime factor is 2. It's 2 going to 16, yes. 16 divided by 2 is 8. Does 2 go into 8? Yes, it does. So I write it down. 8 divided by 2 is 4. Does 2 go into 4? Yes. So I write it down. 4 divided by 2 is 2. Does 2 go into 2? Yes. 2 divided by 2 is 1. So 16, I can rewrite it as 2 to the power 1, 2, 3, 4. This is the longer way of doing it. 2 to the power 4. Now there's an n on top. I include it. I think, let me just see. There should be a way of doing it in the calculator. So you say 16 equals to, there we go. And then I'm looking for fact. Yeah, okay, if you see fact, you see there's fact there. Fact. That fact is orange. So I should hit shift fact. And it's always going to give me the product of its prime factor. So 2 to the power 4. Either I use my calculator or I do this long tree method. Okay, but either way, change it. Cool. Now, everything is in terms of 2, which means I can just have them all in one line. So 2 to the power 2n. Remember, when you're multiplying the same bases, you add exponents. So plus 2n plus 1. Okay. If you had not put this one, you would have probably forgotten it, because it's just times 2. You would have probably forgotten it. So it helps to put it. Now this base is divided, and remember, whenever you divide bases, you subtract exponents for n. Okay, let's see now what finally it gives me. 2n plus 2n is 4n. 4n minus 4n is 0. I can write that 0 plus 1. 0 plus 1 is just 1, so this is 2 to the power 1, which is equals to just 2. There we go. It's our final answer. Okay. Oh, we got another question 4. This time we've got 4.3. And it gives me 5 to the power 2x minus 1 times 9 to the power x minus 2 divided by 15, 2x minus 3. Okay, remember everything must be a product of its prime factors. Is 5 a prime factor? Yes, indeed it is. So it stays as 2x minus 1. Now, how do I rewrite 9 as a product of its prime factors? Let's do that calculator thing I just taught you. So I say 9 equals, and then shift fact. So it's 3 to the power 2. So then I'll go 3 to the power 2. And then these ones, I'll put them in a bracket, x minus 2. The other exponents, they are 1 unit. Okay, divided by, let's do the 15. So 15, I'll go 15 is equals to shift fact. It's 3 times 5. So I'll put that in the brackets, 3 times 5. And then outside I have 2x minus 3. Okay, let's move. So from here, I'm just going to rewrite 5 to the power 2x minus 1 times 3. 2 times x is 2x. 2 times minus 2 is minus 4. Cool. This side, to get rid of the brackets, remember the law here is that we multiply every exponent that's outside with each of these numbers. So here I will have 3 to the power 2x minus 3 times 5 to the power, same thing, 2x minus 3. Okay, now I can rewrite everything as one line, starting with the 5, 2x minus 1. Remember, when I divide bases of the same number, I subtract the exponents. So this one is gonna be minus 2x. This one is gonna be minus negative 3, minus 3, minus negative 3, which is a positive 3. Okay, now let's do the 3. It's 3 to the power 2x minus 4 on the top, and then at the bottom we're dividing same basis, which means I subtract the exponents. So the first one is going to be minus 2x. The second one is minus negative 3, which is a positive 3. Okay, now let's combine like terms. I have 2x, let me just write 5. 2x minus 2x gives me 0. Minus 1 plus 3 gives me plus 2. Okay, let's go to the 3. Minus 2x minus 2x gives me 0. And then minus 4 plus 3 is minus 1. All right, it's minus 1. It's minus 1. So 5, 0 plus 2 is 2. 3, 0 minus 1, it's just minus 1. So I can rewrite this as 5 to the power 2 over 3, because remember, when you have a negative exponent, it goes to the bottom. Or I can say 5 to the power 2, which is 25 over 3. That's my final answer. That's it. Let's see, are we done with question 4? We are done. Yes, indeed. That was the last one. We're ready for question 5 now. Okay, let's do question 5 now. It says solve for x, starting with 5.1, and we've got 2x plus 2 is equals to 1. Well, when solving for x, I'll always put x on the variables on one side and then numbers on the other. So I've got 2x is equals to 1. If I take this 2 to the other side, it becomes minus 2. And then I've got, and then I just want to divide both sides by 2 to get rid of that one. So I'm left with x is equals to 1 minus 2 is minus 1 over 2. That's it. Let's move to 5.2. Now 5.2 says we've got a 4 and then 2x minus 9 close bracket minus 4x is equals to 4 minus 6x. Okay, like I said, variables on one side and numbers on the other. But since we have a bracket, let's expand this first. That's why we did the topic of expansion, because we'll need it here. 4 times 2 is 8, and then x there. And then 4 times 9. Ooh, I need a calculator. What's 4 times 9? Come on, calculator. 4 times 9 is 36. So it's minus 36. And then I've got minus 4x. Everything else stays the same. It's equals to 4 minus 6x. Okay. I don't need this equal sign. Okay, variables on one side. I've got 8. I suggest you put this in a calculator. Minus 4. So minus 4. And then when I take this to the other side, when it comes this side, it becomes plus 6. So then I have 10x is equals to. Now for this side, I have a 4. And then I want to bring this number to that side, right? So it becomes positive, and it becomes plus 36 is 40. And then to get rid of this 10, divide both sides by 10. X is therefore equals to 40 divided by 10 is just simply 4. There we go. Thank you, Mr. Calculator. Let's go to 5.3. So 5.3, what do we have? We have x plus 1 and then 3x minus 1 is equals to 0. Now I know what you are planning to do. You're probably planning to multiply this out, but no, don't do that. From here, we can just say the first bracket, which is x plus 1, is equals to 0. And also, this bracket here, which is 3x minus 1, is equals to 0. So separate them and make both of them equals to 0. Then you can solve for x. Here, x is just simply equal to negative 1, because when we take it to the other side, it becomes negative. And then this side, if I take this to the other side, it becomes 3x is equals to a positive 1. And then I need to get rid of the 3, such that my x therefore is equals to 1 over 3. That's it. So I've got two answers here. X is equals to a negative 1 and x is also equals to 1 over 3. All right, let's move. Almost done, guys. Almost done. 5.4. This time I have x plus 2 over a is equals to bx. Now, what does the question want? It still wants x, right? What did I do here? Let me just rub it. Bx by 10. So this is making x the subject of the formula. So the first thing I want to do is get rid of the fraction by multiplying both sides with a. Then I'll be left with x plus 2 is equals to a bx. Now I want variables on one side and numbers on the other. So I'll have x. I'll bring this whole thing, the whole expression this side becomes minus abx is equals to, I'll take this 2 to the other side, it becomes minus 2. Now, between these two, I factorize. That's why we did the topic of factorization, because I'll need it. Take out the common factor to get x. I multiply x with 1 minus, to get this whole expression, multiply x with ab. Right, and all of this is equals to minus 2. Now, these things are multiplied. I need to get rid of this bracket by dividing both sides with it. Okay, which is 1 minus ab. Therefore, x is just simply equals to minus 2 over 1 minus ab. Good. It's our final answer. Okay. Are we getting there? There's another question. 5.5. This time I have 5x plus 3 times 5x plus 1 is equals to 400. Okay, what I'm going to do is separate these. This one stays as 5x plus 3 times 5x times 5 to the power 1 is equals to 400. So all I did was just expand this, break it down. And then I can now factorize. That's why we did the topic of factorizing, because I have a common factor of 5 to the power x. Now, to get 5 to the power x, I multiply it with the 1. Plus, here, I multiply it with 3 times 5 to the power 1. That's equals to 400. Now, to get rid of this whole thing, I divide by it. 1 plus 3 times 5 to the power 1. And I divide both sides with that thing. 1 plus 3 times 5 to the power. Please, this is not a decimal. It's a multiplication sign. Now what I'm going to do is put this whole thing in a bracket, so that I have 5x is equals to 400 divided by bracket 1 plus 3 times 5 to the power 1, which is just 5. And then I get 25. See that? So I can rewrite 25 in terms of 5, which is 5 to the power 2. Now, when you have the same bases, it means the exponents are also the same. Therefore, this time x is equals to 2. That's it. We are done. Thank you, Mr. Calculator. Let's go to the next question. Is it the last one now? No, it's not. We've got 5.6. It says solve for x and represent the nth So on a number line and in interval notation. Okay, let's do it. 3x plus 4 is greater than 5x plus 8. So what I'm going to do, same thing, same principle of having variables on one side and numbers on the other. So I'm going to take this 5 to the other side, to this side, such that it becomes 3x minus 5x is greater than. Here I'm left with the 8, but I want to bring this number to the other side, which is minus 4. So 3 minus 5, that gives me a minus 2x is greater than 8 minus 4 is 4. Now, there is a rule that if you divide by a negative number, both sides by a negative number, you have to change the sign such that it's x instead of greater than. Now it becomes less than 4 divided by negative 2, which is negative 2. Okay. Now the question said represent this in a number line. So if I have a number line, there we go, that's my number line. All I need is the number negative 2. So negative 2. Now watch this. Because it's a less than sign and there's no equal sign there, it's a open circle. Open circle, not closed. And once it's open and numbers that are less than 2 are on the left, so I put my arrow going that way. This is the number line. The question said and interval notation. So how do we do interval notation? We say open bracket, remember this side is from negative infinity. Open bracket from negative infinity to negative 2, and then you close the bracket. Now this is the interval notation. Interval notation. Let me just write it. Interval notation. Okay, that's it. Okay, let's go to the last question. This is the last question, which is 5.6. Solve for x and y. This is simultaneous equations now. I've got 3x plus y is equals to 2. And then I've got the 6x minus y is equals to 25. So let me name them. This will be my equation number 1. That will be equation number 2. Which one is the easiest to create? Equation number 3? Well, let's go for equation number 1. Let's create equation number 3 using equation number 1. So I'll make y the subject of the formula, and then it becomes 2 minus 3x. This then is my equation number 3. Now I need to put equation number 3 into one of these equations. Let me just say, you cannot put it in the equation that you use to create equation number 3. So I use equation number 1 to create I used equation 1 to create 3, which means I can only put 3 into, I'm using a substitution method, substitute it into equation 2. All right, now let's look at equation number 2. Equation number 2 is this one. It starts with the 6, so I write down a 6. It has a x, so I write down the x. It has a minus, so I write down the minus. It has a y. Now where it has a y, I substitute this whole expression. which is 2 minus 3x, because that's what y is equals to. And then it has an equal sign, put an equal, and 25, put a 25. Now let's expand. This is why we did the topic of expansion, of expanding. Minus 1 times 2 is minus 2. Minus 1 times minus 3 is positive 3. And then there's an x included, which is equals to 25. Now we need to solve for x. So variables on one side, I have 6 plus 3, which will give me 6, 7, 8, 9 x. And then I take this 2 to the other side, and then it becomes 25 plus 2, which is 27. Divide both sides by 9. So my x is equals to 27 divided by 9, which is 3. Are we sure? If you're not sure, let's go to the calculator. 27 divided by 9. It's 3 indeed. So x is 3. Now, which one of these three equations are you going to use to solve for y? You're always going to use equation 3, which is y is equals to 2 minus 3x. Now, because we have the value of x, that means where now we have an x, we'll substitute 3, the value of x. Then just put this in a calculator, which is 2 minus 3, open bracket, put it exactly as it looks there. And then it's minus 7. So, therefore, conclude x is equals to 3 and y is equals to minus 7. That's it. We are totally done, grade 10. We are totally done. Well, thank you so much for staying up until this far. I hope you ace your test, as this is a revision for your test 1. We have tried our best to cover all bases, and this should be enough for you to ace that test. I am hoping that you will get 100% or at least a distinction. If you get a distinction, comment down here and let me know that you got a distinction. Thank you so much.